So we can use models to reason about variables and write equations to help us solve word problems. When I look at this word problem, it tells me that my math class has 31 students. 17 of those students are girls, and the rest are boys. So we can use a model to help us understand what's going on in this problem. The model I'm going to use is going to be a tape diagram. Now, when you have a tape diagram, it's important to understand that these two rectangles are equal to each other. You can tell that because they're the same length. So that means that the amount or the quantity in this top rectangle here is going to be equal to this bottom rectangle down here. So let me show you how that can help us create a model. I know that my math class has 31 students. That's the total amount in my class. So this top rectangle is going to represent my 31 students. Now I know that my class is made up of boys and girls. So what I'm going to do is I'm going to take this bottom rectangle and split it up. One section over here will be my girls, and this section over here will be my boys. Together, the boys and the girls total the 31 students. So in terms of girls, I know I have 17 girls. And all I know is that the rest of my students are boys. Since I don't know exactly how many students that's going to be, I call it with a variable, b. b is the number of boys I have. Now looking at this, we can tell that this amount right here, all of my girls and all of my boys, are the same as all of the students in my class. That's really important because what we're going to do is we're going to take this model and use it to help us write an equation. So I can say that the 17 girls plus all the boys, even though I don't know how many boys there are, together equal my 31 students. I can write it another way if I wanted to. I could say my 31 students is equal to all the boys in my class plus all the girls in my class. Now, you'll sometimes be asked this question, does the variable represent one value or multiple values? Well, in this case, there's only one number that we can make this sentence true. Okay? If I did 17 plus 14, that's going to equal 31. That means the only number that b could be is 14. So this variable has only one value. Because if I were to put another number in, like 10, then 17 plus 10 would not equal 31. It wouldn't make this sentence true. So this problem has only one value for its variable. So let's look at this situation here. It says I put the same number of cookies onto 5 different plates. How many total cookies did I start with? Well, again, let's look at a tape diagram. My tape diagram is going to have 2 rectangles. One is going to be my total number of cookies, but I don't know what that is yet. The second is going to be my 5 plates. So the first thing I'm going to do is break this into my 5 plates. So I know that I have this plate here that has some cookies, and this one has some cookies, and this one has some cookies, and this one has some cookies. Now the problem is they never told us how many cookies are on each plate. So instead of being able to put a number in each of these boxes, all I know is that I have some cookies. So I'm going to use this variable c to represent the number of cookies on each plate. Now it's really important for us to know that all of these c's have to be the same because I have the same number of cookies on each plate. So c is going to stand for my number of cookies on each plate. Now if I have c and c and c and c and c, that's the start of my equation. But what's it going to equal? I don't know what number it is. But what I can say is all of these plates of cookies together is going to equal 5C. So I can see that all of those rectangles on the bottom together are the same as this one rectangle on the top. So if I were going to write this equation, I would say C plus C plus C plus C plus C, that's 5 of them, 1, 2, 3, 4, 5, is equal to 5 times C. Now, we're asked to write two equivalent equations. This one's a little tricky because if I were going to write an equivalent equation, I could use repeated addition or multiplication. Now, this equation, this 5 times C, almost looks exactly like this 5 times C, but because this has a symbol in it and this one doesn't, we technically say that's different. But let's look at this now in terms of whether this variable has one value or lots of values. Well, this one's going to have multiple values. And the reason it's going to have multiple values is our total number of cookies is going to be determined by how many cookies are on each plate. If I were to put 2 cookies on each plate, that would be 2 plus 2 plus 2 plus 2 plus 2, which would give me a total of 10 cookies. Okay? But let's say that I had 7 cookies on each plate. If I had 7 cookies on each plate, 7 plus 7 plus 7 plus 7 plus 7, that's like having 5 plates with 7 cookies. That would give me 35 total cookies. So depending on how many cookies are on each plate, that'll determine how many total cookies I have. And because we can put in lots of different numbers for how many cookies are on each plate, this variable can have lots of different values.